All right, let's dive right in. Today, we're talking about a concept that is absolutely critical for any professional JavaScript developer: inversion of control. We're going to see how a tool we use every day, the callback function, can actually hide a massive risk in our code, especially when we're building big, important, enterprise-level software. So let's get to it.
You know, this quote just nails the personality of JavaScript. It is synchronous. It's single-threaded. What does that really mean? It means it does one thing at a time right now, and it does not wait for anything. So what happens when we actually need it to be patient?
And that's really the heart of the problem, isn't it? In the real world, things take time. We have to go get data from a server. We have to wait for a user to click something. We might just need to pause for a moment. How on earth are we supposed to manage that when the language itself is built to just go, go, go? Okay, let's make this super simple. Imagine this. You need to run a piece of code, say, just log a message. But you don't want it to run now. You want it to run exactly 5 seconds from now. How do you tell JavaScript's engine, which is always in a hurry, to just wait?
Well, this is where our hero enters the story, the callback function. This is the classic, powerful solution for dealing with this kind of thing. It's how we tell JavaScript, hey, I need you to run this code for me, but, later.
So what is a callback, really? It's just a function that you hand over to another function. You're basically saying, here, take this piece of my program. I trust you to call me back and run it when the time is right. You're passing it off.
And using something like setTimeout, this solves our 5-second problem perfectly. We wrap our code in a function, we pass that function, our callback, over to setTimeout. JavaScript doesn't stop. It keeps right on running whatever's next. And then, 5 seconds later, boom, our callback gets executed. We've handled time without freezing up our entire program.
And let's be really clear here. This is an incredibly powerful idea. Callbacks are fundamental to how async JavaScript works. They are not a bad thing by themselves. They're an essential tool in our toolbox.
Okay, so a simple timer is one thing. But now let's apply this to something much more complex, something you'd actually build: the checkout flow on an e-commerce site.
So think about it. In a checkout, you have a chain of events. First, you have to create an order with the items in the cart. Only after you have an order ID can you move on to payment. And only after the payment is confirmed can you show a summary. Every single step depends on the one before it.
So how do we manage this sequence using callbacks? Well, this is where we run into our first big problem, a really infamous pattern that developers have a special name for: the pyramid of doom. It starts out innocently enough. To make sure payment happens after the order is created, we just pass our payment logic as a callback to the createOrder function. Simple, right? Finish task A, then automatically start task B. Makes sense. But then, we need to show the order summary after the payment goes through. So we do it again. We nest another callback inside the first one. And you can already see what's happening, can't you? Our code is starting to grow sideways, pushing farther and farther to the right. And finally, we add the last step, updating the wallet. And there it is. This mess, this deeply nested, hard-to-read shape is what we call callback hell, or the pyramid of doom. It's a complete nightmare to maintain. But here's the kicker. As ugly as this is, it's just a symptom of a much, much more dangerous problem. Because the real danger here isn't about messy-looking code. It's about something way more fundamental. It's a problem of trust. And it's a problem of control that can have serious, real-world consequences. So I want you to really think about this for a second. When you take your super important proceed to payment function and hand it over to that createOrder API, who is in charge of running it now? It's not your code anymore, is it?
This is it. This is the core idea. Inversion of control. You have literally inverted or flipped upside down the control flow of your application. You've given a critical part of your business logic, the part that takes money, to some other function, and you are just blindly trusting it to do the right thing. And this is where the risk becomes terrifyingly clear. What if that createOrder API is just buggy? What if it never calls your payment callback and the customer is just left hanging? Or, and this is the real nightmare, what if some weird bug causes it to call your payment function twice? You just charge the customer double. In a professional system, these aren't just bugs, they're catastrophic failures. And it happened because you gave away control. So as you can see, we've really dug up two very different issues that come from this pattern. And it is so important to understand the difference, because one is about neatness and the other is about genuine risk.
See, on one hand, you've got callback hell.
That's a readability problem. It's annoying, it's hard to debug, it's a maintenance headache. But then you have inversion of control. This isn't a headache. This is a problem of trust and architectural soundness. You are putting the reliability of your program into someone else's hands.
And that right there is the key takeaway for today. While a lot of us get fixated on the ugly code of callback hell, the much bigger, much scarier monster hiding in the shadows is the inversion of control. In the world of professional software, where things have to be reliable, just handing over control like that is a risk you often can't afford to take.
Which, of course, leaves us with the million-dollar question. We've seen how easy it is to lose control of our own program, so how do we get it back? Well, that's a story for another explainer. I'll see you next time.